All right, I'm going to be sharing some information on Cnidaria, and that's going to cover animals like box jellies, sea jellies, coral, sea pens, all these creatures that you see here on this screen. So there's four main classes within the phylum Cnidaria: um, the Anthozoa, Cyphozoa, Cubozoa, and Hydrozoa. Although some sources that I found included a fifth class, this Staurozoa. Um, but I'm just going to go with the four because I'm not 100% clear on whether I should include that. So we'll just stick with this four. All right, general information. The Cnidaria could have appeared in the fossil record as early as the late Precambrian. Um, and so I guess that's kind of like a debate amongst paleontologists. They're very diverse in size and shape, so their morphologies are very different, as you can tell, like if you look at a coral versus a jellyfish. Um, and that leads me to also share with you that these are still obviously extant. They exist today. They're not extinct. Although at one point in time, some species, obviously, probably many species went extinct, but many of these animals within this phylum exist today. So, yeah, they vary in size and shape. So some of these organisms are millimeters, and some are meters, tens of meters long, like tentacle wise. Um, so they're simple invertebrate, no skeleton, no head, no specialized organs for digestion or respiration. And I'll show you a slide here in a second, a kind of diagram to show how simple they are physically. Um, so they mostly live in a marine environment like oceans, except there are some hydrozoa and cyphozoa that can be found or that have been found in rivers and lakes. So some freshwater organisms. And they also develop and live throughout the water column. Um, so in the form of polyps, um, meaning they're anchored to something, and then that's how they're born, and that's how they live their life. And there's also what's called the medusa, meaning that they're pelagic, I think is how you say that, meaning like free floating or free swimming. And the trait that's shared among all the Cnidaria that can be traced to a common ancestor are the nematocytes. And these are the stinging portion of these animals. They're kind of like miniature harpoons. So this is the diagram here. We have somewhat, a box jelly or jellyfish type of organism showing the different tissues and compartments within the organism. And here's a polyp sort of thing, sort of like an anemone. This mesoglia probably. That's that gelatin sort of substance that the body's composed of. And the tentacles, obviously. Also, their mouths are the anus, right? So they intake nutrients and then they, excrete nutrients from the same opening. That's pretty much what I wanted to cover on that. And then here is an example, a diagram showing the different stages in life of the various organisms within Cnidaria. So you have fertilized egg and then this larva, but some of the organisms obviously stay polyp, and they might get to this level here, like a more advanced, like stacking. But many, the majority, I think, are the pelagic, where they break free from whatever they're anchored to, and then they live their life like as a jelly would, floating around. Right. So the first class I want to talk about is Anthozoa. So this include your corals, your anemones, your sea fans. I don't have a picture of a sea fan here, but I do have a picture of a sea pen. That's very interesting. So the Anthozoa are excellent because they're composed of hard parts, which are really good for fossilization. And so these contribute to the length of fossil record. Like they're really well known deeper in time compared to obviously jellies, which are 90% water, very difficult fossilization. It's a very difficult environment to fossilize something that's made of 90% water. And so here's an example fossil from the Silurian of a coral of some type. And the Anthozoa don't have, obviously, a medusa stage. They're just polyps, and they live in shallow marine environments. The Scyphozoa, these are sea jellies, or commonly known jellyfish. They are pelagic, meaning they swim around. Again, 90% water. Really, really unique conditions in order to get a fossil. And here, there's a fossil from late Jurassic of a jellyfish. They have, I think, 4 oral arms surrounding the mouth, and then a bunch of different tentacles hanging off them. Here's the Cubozoa, box jellyfish, or not jellyfish, box jellies. They're also made of mostly water, and there's not a ton of, actually, I'm not sure if there's like a bunch of fossils or not, but again, if you have no hard parts, it's more difficult to be fossilized. An interesting thing about these box jellies is they have eyes, right? So that's pretty interesting, being that these are simple creatures, and that they don't have any very intense nervous system. So these box jellies have eyes. Pretty interesting. And then here's a fossil from the Pennsylvanian of a box jelly, Cubozoa. All right, Hydrozoa. I think this is my last class within the phylum Cnidaria. And so here we have a picture of the Portuguese man of war. Can be lethal. We also have a fire coral, and I believe, I forget exactly what animal this is, but this is a fossil from the Cretaceous. The article I read said that it was a rare fossil. They can be either pelagic, meaning floating around, swimming around, like the Portuguese man of war to the left there, or they can be anchored, like the fire coral. And this is the class where you can find some freshwater organisms. Right, and then I think that might be the fossil here is this stylesterine, or I'm not sure how to pronounce that. But anyways, that's the phylum Cnidaria with the 4 classes. And so that's all I have for you. Have a great day.